MgcSTEM PWM 2.0a. Mode C. Battery Adapter Upgrade Solution. Hello everyone. Today we'll create a video tutorial on the wiring connections for upgrading power wheels using the PWM 2.0a module in Mode C, combined with a variable speed pedal, a 3-pin resettable pedal switch, a 6-pin shifter, and a multifunctional battery adapter. After upgrading with this solution, you can directly use 18V/20V DeWalt tool batteries to enhance the vehicle's power and speed. It enables variable speed control, braking, soft start, and 3 gears. Forward, stop, reverse. While retaining the original 12V system features such as lights, horn, and Bluetooth. Both soft start and soft stop functions are included to protect the gears in the transmission. The battery adapter's low voltage protection prevents battery damage from overdischarging. The physical connection method uses a multifunctional battery adapter as the power source, with 2 separate output lines. 1. Motor power circuit, battery voltage supply. The battery voltage flows through the fuse, brake switch, PWM module, and shifter to the motor. Note: for dual motors, connect them in parallel. To ensure both wheels rotate in the same direction, cross-connect the terminals. Connect the positive terminal of one motor to the negative terminal of the other, and vice versa. 2. 12V voltage circuit. Dedicated to powering lighting, audio, and Bluetooth. Note: connect the 12V output directly to the original vehicle's battery wires and remove the original battery. This 12V line supports a maximum current of 2.5A. Let's look at the circuit connection diagram. I'll explain it in the order of current flow from the battery to the load. First circuit, battery voltage to motor. Power circuit. The battery's B+ terminal connects to the fuse. The fuse connects to the brake pedal. Brake principle. When the brake pedal is pressed, pins 2 and 3 of the pedal are disconnected, while pins 1 and 2 are connected. This cuts off the battery's connection to the PWM module, stopping its output. Additionally, since the PWM module's P+ and M+ terminals are internally connected, pressing the brake pedal while the vehicle is moving shorts the motor to generate reverse braking force, achieving a braking effect. When the pedal is not pressed, pins 2 and 3 are connected, and pins 1 and 2 are disconnected. Current then flows through pin 2 to the PWM module's P+ terminal. After modulation by the PWM module, current flows from the PWM's M+ terminal to the shifter, then through the shifter to the motor's M+ terminal. Finally, current returns from the motor's M terminal through the shifter to the PWM's M terminal. After modulation, current flows from the PWM's P terminal through the main switch to the adapter's G terminal, then to the battery's negative terminal to form a closed loop. Second circuit, original vehicle's 12V voltage circuit. Connect the 12V output terminal to the original vehicle's positive battery wire. Connect the original vehicle's negative battery wire to the main switch or PWM's P terminal. Current flows through the switch back to the adapter's G terminal to form a closed loop. Skip this step if using an adapter without 12V function or if 12V is not needed. This replaces the original battery with 12V from the adapter. Remember to remove the original battery, allowing the original 12V components to work normally. Note: the adapter's internal 12V DC-DC supports a maximum current of 2.5A, which is generally sufficient for original 12V components with some margin. If adding extra 12V devices, e.g. additional lights, calculate the total power to avoid exceeding this limit. Overloading will trigger overcurrent protection or a short circuit, causing a full power cutoff. The entire wiring must follow this diagram's order. Plug the variable speed pedal into the PWM's plus 5GP port. Flip the PWM switch to the inner side. Position 2 as per the manual. Adjust the potentiometer knob to set the total output power. Turn clockwise to maximum for higher top speed. After these steps, insert the battery into the adapter to activate the module. Set the battery adapter parameters. Default settings usually work, and the system is ready for use. Advantages of this upgrade compared to the original setup. 1. Upgrading from 12V to 20V significantly boosts the vehicle's power. 2. The built-in 3-second soft start reduces startup impact, effectively protecting the gears and the transmission from damage and making driving safer and more comfortable. 3. The variable speed pedal allows speed control by adjusting the pressing depth. Press harder for higher speed and lighter for lower speed. 4. Equipped with a brake pedal. Simply press it to stop while driving, which better simulates real car driving and makes children's play more enjoyable. 5. The multifunctional battery adapter provides programmable low-voltage protection, preventing costly battery damage from over-discharging. Its built-in 12V output port supplies power to the original vehicle's lights, horn, etc., eliminating the need for separate upgrades of these accessories. It is a cost-effective and high-performance upgrade method. Note: the PWM 2.0 features resettable overcurrent protection. When the peak continuous current exceeds 35A or the peak current exceeds 20A, the automatic overcurrent protection function is triggered to limit output, which will reduce the power value and maintain a continuous output current of 20A. It will automatically resume normal operation when the current decreases, with no need to replace the fuse. I'll explain the brake pedal installation method in detail for PWM 2.0A in Configuration C mode. In this mode, the vehicle speed is controlled by the variable speed pedal, so the PWM module needs to remain powered. Therefore, the brake pedal must conduct current to the PWM module when not pressed. When braking is needed, pressing the brake pedal will cut off the connection between the battery and the PWM module, stop the module's output, and short-circuit the motor to generate reverse braking force, thereby achieving the braking effect. When the brake pedal is released, power will be restored to the PWM module and the module will restart. Note: when both the variable speed accelerator pedal and the brake pedal are pressed simultaneously, the variable speed pedal will be inactive because the PWM module is in a power-off state. Releasing the brake pedal will restore the function of the variable speed pedal. The connection method for the shifter is slightly more complicated. To avoid errors, a detailed explanation is provided later in the playlist.